what do you imagine when we say AI? Now, try to imagine what AI itself actually looks like. If we look beyond the code and try to visualize AI working, what comes to mind, Eunice?
A very technical image, like a bunch of code interacting with each other and interlinking different databases.
Yeah, that sounds about the same for myself too. Something very pie in the sky, maybe a coder sitting behind his computer. I personally, I don't come from an AI background, so to me, it's a very much a mystery black box. So I want to welcome all our guests, all our attendees to Innovators, powered by Montreal New Tech. It's a show about people and companies, organizations who are changing the world through innovative ideas, technology, and science.
We are your hosts, Eunice Mercado-Lara and Dennis Lucian. On the last episode of Innovators, we dove into the ethics and the hype around artificial intelligence. Today, we want to build on that conversation and to take a look at AI, but through a different lens. Right. Today, what we want to do is to talk with two visionaries who set out how to make AI more accessible, democratic, and impactful, especially for those who are not coders, but who can actually see the value and the potential of AI.
Awesome. Thank you so much, Eunice. So please, you'll see there's a little icon at the bottom of your screen. Click that to give a big round of applause to our amazing guests. And welcome to screen Guillaume Hervé and John Magoon. So two of the three co-founders of Zetane Systems developed in our own backyard here in Montreal. Welcome, John, Guillaume. How are you guys doing today?
Oh, very well. Thank you. Thanks for having us.
Yeah, thanks for having us.
It's a pleasure. So what is the most exciting AI news you've heard this month?
The most exciting AI news this month, I think, is the fact that like on a monthly basis, we're seeing so much investment going into AI companies. But what we're seeing, which is different than 3-4 years ago, is I think these AI companies are more focused on what they're bringing to businesses and how they're impacting, the world around them. Whereas 3-4 years ago, it was a lot of just throwing money at different concepts and see what sticks. So I think there's more of a focus in the world of AI today than it was just not that long ago, really.
That's great news. It's a very quickly developing industry, so it's great to see that things are progressing. Anything on your end, John?
Yeah, just there's so much research that is always happening in the AI field, and seeing some of the new models that are capable of achieving kind of state-of-the-art results, but use a variety of different architectures, so transformers, and then new models that also use a similar mechanism as transformers called attention, that perform just as well as Google's large models have been released in the past month with state-of-the-art image recognition abilities. It's very fascinating to see how the field is developing.
That's very, very cool.
That's cool. So guys, before we dive into the serious questions, we have a tradition here at Innovators to kick off things in a fun and a lighthearted manner. So today, what we are going to do is we are going to face off our guests against our audience in a battle of an AI trivia. And I don't know, Dennis, who do you think will be victorious?
That's a great question. So we're going to pitch you guys against our audience, and let's see who knows AI trivia better. So this is the interactive part of the show. We promised this to everyone, so here it is. We'll need you to pull out a secondary device like your phone, or if you don't have a phone available next to you or you're using your phone for the show, you can always open a separate tab. Just make sure not to close this one, otherwise you'll leave the show. So and then once you're open up your browser, go to the website called www.menti.com and type in the code 74973148, and you'll be able to join us in the game and compete against our guests in live real time. So we'll give you guys a couple minutes to join us there.
And while the audience join us for the dynamic, I want to just give you a quick idea on who's on the on the show today, because Guillaume, I found out that not only you are part of an organization that's doing so much within the Canadian AI community, but you are also an author of a published book. Would you like to tell us about it?
Yeah, thanks for asking that. That's interesting because it actually does lead into what we're doing at Zetane. So I published a book on corporate entrepreneurship, which is intrapreneurship, entrepreneurship within companies. And it's based on some of the work I had done. I had launched startups inside companies. One of the bigger ones became what is CAE Healthcare, where we took concept of pilot training, which uses a lot of modeling and simulation, and ported that know-how and technology into the world of healthcare. And so having done several startups within companies, I ended up not only launching that book, but that book led me to becoming a mentor at places like Techstars and Founder Fuel and District 3 here just in Montreal and a few others. So it was an exciting journey, which didn't have a destination when I started it, but like all journeys, they're fascinating. So yeah.
And those are the more exciting ones. That's impressive. Thank you. John, just a quick question. You completed your education in Louisiana.
Yeah.
Out of all the places you could have possibly ended up, and how have you ended up starting a company based in Montreal?
Yeah, well, my background is in philosophy, not software development. So I'm a self-taught software engineer, and I'm a self-taught AI and ML developer. And I've met Patrick and Guillaume. It's kind of a long story, so I won't go into it too much. But we all had a passion for making this kind of complex field more accessible to people. My background is learning online, teaching myself through textbooks. So the idea that AI and machine learning, which is complex, but it's definitely understandable, could be more accessible to a larger range of people, was appealing to all of us. And I think we all share that kind of that teaching background. And Patrick was a professor, and Guillaume already mentioned his mentorship and his writing. So it's definitely it's something that we all connected on, and we were all interested in developing farther.
Okay, thank you for those warm-up questions or answers. So Dennis, how we are for the
I'd say we're ready. Let's do it.
Okay.
So make sure you're ready for the game here. It's about to begin. Awesome, we got a bunch of people here, so it should be fun. Here's the first question. The Terminator was originally supposed to have which animal sidekick? Five, 4, 3, 2, 1. Very nicely done. 8 people got the same answer. It is indeed the dog.
Like the Boston Dynamics one, basically? That was what he was supposed to have.
Yeah, I think it's getting close to the reality nowadays. All right, question number 2. Oh, that's my bad. I think I clicked too soon. Let's skip to the next one. Oh, sorry guys, something's weird is happening on my end here. Let me just reset that a little bit. The difficulty of trying out new things.
Mm-hmm. All good.
Okay. All right. You guys might have seen some of the answers. It's okay. Just close your eyes. Pretend you didn't see them. All right. I am not sure what's happening here. I am so sorry. Okay. Let's try that again. All right, there we go. So which one of these is the real domain of artificial intelligence?
Is it bad if we get this one wrong after seeing it?
We will judge you very harshly.
Okay, all right.
I tried to make this one as deceiving as possible, so don't feel too bad. So yes, fuzzy logic is the right one. It's the approach to computing based on degrees of truth rather than the actual true or false questions. And John and Jay take the lead. Well done. Oh man, okay. Something weird's going on with my technology today. So we'll call it a day for the game. You try, sometimes they fail. It's okay. We'll get it better next time. I appreciate everyone for trying it out with us today and playing along. I know I enjoyed it when we were testing it out the other week because everything worked well during testing. So
that's how it always goes. It's how it always works.
Okay, so let's dive into the real interview because there's a lot of stuff I wanted to go over. Time's going by fast already anyways, so let's jump right in. So the reason why we got you guys here today is to talk about Zetane and the Zetane engine. So you're developing some really, really cool stuff. And so can you explain to us in layman's terms, because that's the whole kind of core of what you guys do too, is making AI accessible. So tell us about what you are developing. What is your innovation?
Sure, I can start, and certainly Jonathan can dig in. You know, I guess the best example is when I ask people, "Are you a doctor?" Like Dennis, are you a doctor?
No.
No. Okay. Have you ever seen an MRI or an X-ray or a scan?
I've seen an X-ray maybe once or twice in my life, and primarily maybe on TV.
Okay, fair enough. And Eunice, yourself, have you seen these types of? Right?
I've seen that.
Yeah, and you're not a doctor, and neither am I. But the beauty of the MRI or the X-ray is it gives the people that do research in medicine incredible information and insights into developing new, cures, new ways of treating disease. But that same image gives you and me the ability to understand, what is broken and what's not working. And yet we don't need a medical degree. Or the physiotherapist that's going to treat your broken arm or your sprained this and that, right? And so at Zetane, that's what we wanted to do. What we said is that AI shouldn't be left in the hands of solely the data scientists and the machine learning engineers, because if it is, it won't ever really grow into a complete domain that is impacting the world around us. And if you don't make it human understandable the way MRIs and scans are, then you can't hold accountable the people that are giving you the solutions either, right? Because you can't say, well, when you explained what you thought AI was, you weren't far. Both of you were pretty close. But the next usual question that we get is, but how do we know it's working? How do we know it's working properly? How do we know it's not biased? How do we know when it's not going to work? And so what we did at Zetane is we said we need to take this complex set of algorithms, libraries, and code and make them visual so that not just the experts can go further with what they have, but the non-experts can participate, especially in industry, to validate that it's going to work, it's going to be tested, it's going to solve whatever it has to solve, and it can be trusted and explained. So that is the thing. That is the software that we've developed.
And I love how you described it, because at the end, it's also about appropriation. It's okay to have a proper solution for very technical problems, but at the end, in the implementation of the solutions, you really need a degree of appropriation of the population who's actually making lives easier. So on that, what we know so far is that for many people, AI feels like a mysterious black box. You take some data and some code, and then prove the outcome in a smart machine that can help you to solve problems. That's basically the common understanding of this business. So as a person with no AI background, I understand that the value of it, but not necessarily the application of the technology. And I agree with you guys, it shouldn't be a criteria to exclude people from the discussion. So I think there's a disconnection. So how do you help people like me to see the true potential and to understand the application of these technologies without having a real AI background or without becoming an AI expert?
Yes. So I think, you mentioned kind of the perception of what AI is. And, I think people think of AI as, smart or even dangerous, right? And almost in the Skynet sense. I mean, we brought up Terminator earlier, right? But the problem is that models are actually quite dumb. They're very, they're focused on a very specific use case in general, and they're limited in what they can do specifically. And so, that misconception is honestly what leads to a lot of the challenges, because when we're talking about, bringing a model into production or understanding it, what we need to understand is what it actually can do and what it can't do. The can't do is the really important part, because that helps us build robust systems. It helps us, understand how it will fail, why it will fail, and what things we need to put in place to make sure that we can actually bring something into production and get it deployed. So, visualization is a huge piece of that. And Guillaume mentioned, in the medical domain, an AI model that's predicting a patient outcome, it needs to be verified with domain experts, with medical professionals, not just about the outcome, but about what it's doing internally in order to make sure that it's producing the correct outcome for the correct reasons. Because there's a big difference between those two things, right? It could be producing a correct outcome that it's trained to produce for all the wrong internal reasons. And that is possibly an even worse problem, because we think that the AI model is working correctly, is doing what it's supposed to, but it's actually just completely fragile and is going to be completely broken once it starts encountering the real world and unknown situations. So, yeah.
And I think we've seen that, and I know we talked about it last episode as well in the ethics, because it creates some gaps, right? Like you teach it what you're aware of and what you're looking at, or the data you're feeding it, and countless times has been examples of it derailing and going in a completely opposite direction, which we did not foresee at all. But it's interesting when we do talk about kind of the potential future of AI. There's so much more that it ends up doing, and the things we teach it becoming much more autonomous in that sense. But that's where I spoke with your colleague Jason, and the conversation we had kind of pre-show to when we were booking you guys, the concept of making AI more accessible and democratized is very, very interesting. And that's the word you guys use, democratize. So can you tell us a little bit about what do you mean by that? What does democratized AI look like for you?
Well, from my perspective, there's two things. One, it's back to the question of the black box. Right? Because if people don't understand and trust something, they'll fear it. And if you fear it, you won't adopt it. And so how do you break that fear cycle? You let people understand and explain what you're trying to show them to a point where, they're comfortable with it. The problem is that, look at the example today of the game that we tried to play. Let's say that had been an AI algorithm. It wasn't, but let's say that it had been. Well, the risks of the consequence of it not working today were relatively minor. We had a good laugh and you'll learn and it'll improve next time. But let's say that had been a medical diagnostic. Let's say that had been, an interview of hiring somebody. Let's say that it had been monitoring a car that was self-driving, at 120 kilometers an hour on a highway. If it had failed, the risk and the consequence would have been different, right? And so that's what democratizing AI in our speak is all about. We believe that if you can make AI human understandable, if you can do that, you put it in the hands of more people. If you put it in the hands of more people, more industry will use it and put it into the real world, like our world. And more of us will go, okay, it's safe, I understand it, and therefore I'll use it. And it's no different than technologies that have been introduced ever since, the last 20 years, where at first we're all like a little skeptical and scared, right? I remember, the whole genomics field, because people weren't able to explain it and give it into more, generalizations, it scared the, bejesus out of a lot of people for many, many years, until finally people started to realize, there's a lot of good that can come out of it. Same thing for us. Democratizing for us is you need to have more people in industry, not just experts in AI. So developers, technical people, users, consumers of the AI. being able to interact with it in a way that opens up the black box so they can ask all the questions. And Jonathan's example is really good. And then say, okay, I can close the black box now, and I'll trust the future black boxes because you've shown me this one. But today, there's still a lot of resistance in adopting AI because we haven't opened that black box. And the demos you're going to see today by John is good. I mean, they're going to show you what really opening an AI black box.
And I'm personally really looking forward to that. And you know, that example of, for example, Tesla and the autopilot feature, 100% couldn't agree with you more, because you're going to give your life to a machine to do what people have been doing for generations and generations and decades. It's kind of nuts to think of, okay, I'm going to fully trust this thing to have the life of myself, my passengers, other people on the road, especially not seeing, you know, how it's analyzing what it's doing. I mean, you have no idea, no way to kind of even predict what it might do in any specific moment, and that's exactly where that trust is broken. And how do you then interact with AI versus human? That interaction is definitely damaged at that point.
We kind of covered this question, but maybe John, do you want to explain us why do you think this is important? We understand that in the future we're going to rely a lot on AI-driven technologies or AI-driven solutions, but why do you think it's important to you both took the decision to start working on this, like to start changing the discourse and start opening new options and new opportunities for people to jump in, and not only people, also technologies and companies. Why do you think this is important?
Yeah, I mean, I think, you know, AI and machine learning can do some really incredible things. In specific contexts, in specific use cases, right? And so a big challenge is because of how much hype there is, and because of there's kind of a, you know, mixed terminology maybe in the media of like what AI is and what AI isn't. It's really important to build that understanding within an organization or within even an individual who's in the field. You know, what are we actually talking about? Like, what actually can AI do and what can it actually not do? And that's the only way that it will ever be able to deploy it. Because if it's just kind of this generalized thing, this black box or kind of a mystery, it will be impossible to make real progress in terms of not just in research. So, you know, research is just continuing to sprint ahead in what can be done, and it's incredible how much research is being produced every single day. But in terms of industry, I mean, there's a real lag of that research crossing into industrial applications or enterprise applications or small businesses to get some actual value out of all this incredible research that's coming out. And a big part of that is this communication process is actually very challenging. So between an expert and someone who may be an expert but in their business, the ability to understand, okay, how can this technology actually help and not harm us? How can this technology actually bring some value to our organization, to our customers? That's the piece that's really been slow in developing, and that's the piece that we're actually very focused on. That's the piece that's important to us is kind of bringing that research, bringing that you know, whether it's cutting edge or older research, but whatever can actually help an organization. That to me is the important piece, and that's what we're interested in.
Is there an example that stands out in your mind from the partnerships you've kind of created, the work you've been doing, that really shows the impact of what you've put together with the visualization that really kind of helps them break through the next level?
Yeah, sure. I mean, Guillaume, you're nodding. I'm nodding. Feel free to jump in. We may be thinking of the same example. We may be thinking of different examples, but
yeah, I'll tell you. So it's really a good question. When we started Zetane, we were focused on the software product, and it's launched. People can go to zetane.com, download it right now. There's a free viewer on top of it, so the product lives, right? Mm-hmm. But we were getting sucked into companies saying, "Can you help us with the actual projects we're trying to get done?" So we got brought into that field, and we do a lot of that work now. There has been at least 3, 4, 5 examples of us working with an AI team who had been struggling to get their projects approved internally by the business side of the companies, or the decision makers, the operational people that consume the AI that would come out of the innovation teams. And after we've helped them transition their work into Zetane, I was alive there just before the pandemic hit, where they literally took their computer laptop walked over to the VP of engineering and the CEOs, like those levels, C-suites, right? And said, I got to show you something. They showed them in 3-4 minutes the Zatane view of their project they've been working on for months. Immediate acceptance.
Wow.
And I'm not exaggerating one bit. Like, I was there, it happened. And so we started realizing, like, this is really powerful, but people don't know that tool exists, right? But when you visualize something and you're told, like, here's how the data is going to go through, here's what the algorithm, this fancy black box, here's what it looks like, here's what you can trust it, because these are the things we've done, and here's how accurate it is giving you that output, whatever that recommendation is. When you do that visually, and then if you can challenge me and say, but doesn't it make sense that that part should have so much impact, or this part should have more impact, you know? And you say, okay. And the acceptance becomes a collaboration as opposed to me trying to convince you. So yeah, I could give you a bunch of examples. In computer vision, which we specialize in a lot, so that field is an exploding field, but also in regular tabular data, you know, like, why should I trust? Well, I just showed you why. Challenge me, and if I can't answer, I'll come back to you with the answers, which you can do today with Python code and libraries and stuff that you can't get your hands into unless you're an expert.
That sounds exactly like, you know, back in the day when the computers were just becoming a thing and all you had was the DOS interface. And then Apple came up with the visual interface, and applications, people acceptance like skyrocketed because of suddenly you can use it for something. You can understand what to use it for. It makes a huge difference. Yeah,
great example.
So what applications do you see, what applications of AI are you hoping to see and be part of developing with the tools you've created?
So we, like Guillaume mentioned, we specialize in computer vision. Computer vision is an area that I think maybe has less adoption at this point. It's the domain is very interesting, and it's also challenging. The tools that we've created that are visual, they help understand what computer vision models are doing and how computer vision models work specifically, and kind of the challenges and constraints around computer vision models. So it's definitely kind of a passion of ours is working in that industry. We do work with NLP, natural language, and tabular data as well. But the tools that we've developed, the exploration and visualization tools, they kind of create a common language when we're talking about a computer vision model. So that's what we're looking at here.
Thanks, John. So we're kind of coming up close to time for the demo. There's enough time for maybe one more question. And I do want to let our audience know to make sure that if you have a question for John or Guillaume, make sure you post it in the comments. Shortly, we'll be opening up the mics as well, so you can join us on screen if you want to, leave a comment, say something specific about, what we've been discussing, and ask a question directly to our guests. So keep an eye on that. It's definitely coming up. But before we jump into the demo, I do want to kind of touch on one little thing. And piece of that is, one, to congratulate you guys. I know at the end of 2020, you had some really big news with funding coming through. You got $350,000 to work on the Rain Metal project, in part with MEI, the Quebec innovation branch of the government. But also I saw that you received $100,000 from the Canadian Economic Development too. So for huge congratulations on that. That's very exciting news. But I'm really curious to kind of dive into this a little bit, and very briefly, but in terms of promoting innovation from the government standpoint, how does input like this from the government make an impact on your ability to innovate and change the industry and take your project and what you're working on to the next level?
Well, we've been able to get roughly $1.5 million of non-dilutive funding, so some of which you mentioned, and others. We've got some exciting release coming out next week on a gaming company that we can't tell you about yet, granting us $150,000 for what we do. So I would say that on the one hand, one of the biggest struggles I think that companies have in Quebec and Canada is having startup technology get adopted within the government earlier rather than later. By definition, governments are risk averse. So they do a good job of putting money into programs that we benefited from, and we wouldn't be here today without Quebec, provincial and federal, and Montreal, PME Montréal, West Island helped us quite a bit as well, BDC. So we wouldn't be here without them. So that part works relatively well. But the technology adoption piece of saying, you know what, we're going to use Attain in the branch of government ABC because it's going to help us de-risk and understand and explain AI solutions. And yeah, it may not be perfect just yet, but it's pretty good. So let's jump in. I think that's the part that still needs to be developed. And whether it's AI or medtech, because I work a lot with medtechs or other technologies, I think that is a big part. If the government could do that, it would be outstanding, because the rest of the programs are pretty solid. I don't know if that answers your question. Like, is that what? Yeah.
Yeah, I think definitely in part like I said, I'm just touching on the surface of the topic because I know we have a lot of things still planned for the show. So maybe we can continue the conversation after the demo, because I'm very keen to jump into that. John, if you could share your screen, let's jump into this.
All right, let's do it. All right, can you see my screen?
Yeah.
Yep.
Okay, so what we're looking at here is the Attain viewer. Like Guillaume mentioned, this is free for download on our website. And what this viewer is looking at is an AI model. So, we talked a little bit about what an AI model is, but, at its heart, it's a series of statistical and mathematical operations that's going to take input information and transform it into an output prediction. So in this case, I've gone with a real world use case that most of us have probably experienced. So most of us have probably interacted with a banking app where you take a picture of a check, it uploads the check and puts the money into hopefully your account. This is a digit recognition neural network. And so we're looking at a smaller example of a digit recognition neural network that's going to be taking in the input image that is produced by a user of the model, and it's going to transform it into a prediction. It could be a single numeric value or a series of numeric values. And the model is processing that input information and transforming it into that output prediction. And so we're looking at the model input right now. We're going to look at the model. We're going to look at the internal information inside of the model, and then the output prediction that the model is making as it transforms that information. So in this case, the input is a image of a digit, and this digit comes from MNIST, which is a database of 60,000 handwritten images. So it's designed for training models to recognize these handwritten digits. You can see over here this visualization of the input image. It is 28 by 28, so 28 pixels wide by 28 pixels high, and it's colored based on the values of each of the pixels. So this color scheme, red is higher value and blue or purple is a lower value. You can, as a human, it's really easy to see that the drawn two has the highest values, but that's part of the visualization, is we're actually showing the raw values. So this input is basically, you can think of it as a statistical distribution that is passed into the AI model. And the AI model is, it learns over time based on making a prediction randomly at first. It gets corrected by a mathematical function called a loss function to teach the model over and over again whether the prediction it was making is correct or incorrect, and get it closer to the correct output prediction. And so this happens, this learning process is called model training. And when the model trains, it's actually learning information about this input image, this input data, and it's storing that information inside of its internal, what are called weights. These are its learned patterns that it has recognized. And I can show that quickly. So, we're looking at the actual internals of the model here. It's this a similar visualization, but these are the model's weights. So this is the information that the model is learning about the input data that is passed into it. This visualization here that we're seeing of the two, or this kind of colored version of the two, is a combination of this particular input image and the learned weight information. So they're combined in order to produce this visualization. And using that, you can kind of see what the model has learned about the number 2. So this computer vision model is learning things like vertical lines or horizontal lines. It learns about edges, curves. It learns about like the juxtapositions between different strokes. And it also, one interesting thing you can kind of see here, so this is the same color scheme. So redder is a higher value and blue is a lower value. You can actually see that there are parts of the 2 that this particular weight has learned to avoid, right? So when the model is rewarded or punished based on a prediction, it also learns the things that help it differentiate a 2 from a 7 or a 2 from a 3. And so it remembers those things, and it is highly, it pays attention to them in order to differentiate that in the final output. So as the model passes its data through its operations, the input image actually is downsampled, or it gets smaller and smaller. So what happens is the weights. This model, it's the same process happening over and over again as the image passes through and gets smaller and smaller. The weights actually start learning more and more particular features about this kind of image. And so, in a simple model like this, where the image is very small, it may be learning, very particular things about what makes a 2 a 2. It might be just, a group of pixels, maybe, 10 pixels that are influencing this model in its prediction of a 2, saying, okay, this is where the top of the 2 meets the bottom of the 2. That's what makes this a 2 and not a 7 or a 3 or a 9. Eventually, these distributions, they're transformed into a statistical likelihood prediction. And that prediction is going to be what the model thinks this input image actually is. I can show that real quick. So in this case, it's predicting one of 10 digits. So 0 is a digit here. And in this case, it's the same color scheme. So 0, 1, 2, this is the highest valued prediction. So the model is saying, of all these possibilities, this is the most likely prediction of this input image. So that is basically a kind of a whirlwind tour of how a computer vision model works. They get larger and more complex than this, and in a larger, more complex model, they start to learn things that are even more complicated. So a larger model may learn human recognizable features, like in the feature maps that I showed. Maybe the nose of a dog or an eye. It's very common for computer vision models to learn about eyes for whatever reason, or the rim of a car or something. These are all structures that the model will learn to differentiate these different kinds of input images. And based on kind of what we said earlier, you can probably tell that the model is not actually, it's smart, but it's not that smart. It's doing one very particular thing, and it's trying to do a very good job at that one particular thing. But the models can be tricked. And I can just show a quick example that I took last night of an incorrect prediction that this model made. So this is a digit, an input image that was passed into the model of a 9, and the model predicted that this was a 7. So we can look at the features that the model learned to predict, which were diagonal lines, vertical lines, horizontal lines. It sees all of those, and you can see the detection around the 9, but it didn't do a very good job of learning the difference between a 7 and a 9 that's written to look quite a bit like a 7. Just barely has this internal circle. And so the model actually predicts the likelihood that this is, either a 7 or a 9. But in this case, it actually thinks it's more 7, it's more 7-ish than it is 9-ish. So, this is one of those, this is just a simple example and kind of a theoretical example, but in the real world use case of a check, the image may have all kinds of challenges that need to be planned for and need to be mitigated. If maybe the check is not a picture of a check at all, maybe it's too bright or too dark, or some key information is hidden from the check. And so even in a simple case, the systems design in order to get that model into actual production is about knowing what the model can do and knowing what the model can't do, and knowing how to plan for that and how to work around that. So I have more examples. I don't know how much time we have, but
thanks for. I think that was an awesome introduction. Thanks for walking us into this, because sometimes we rely on AI not knowing exactly how it works, but now, at least for the audience and me, it'll be a bit clearer which are the limitations, or what are we talking about when we're talking about predictions and models based on either visuals or other tools. So we are getting close to the interactive part of the show. So what's next is to invite the audience to basically take the mic and make the questions for our guests. And whoever feels like jumping in.
Yeah, so if you want to join the conversation, you have the chat box on the right. So feel free to write in there, and we'll keep an eye on that and pose any questions directly to Guillaume and John. Otherwise, you can click the microphone button, and then you'll be able to actually join us on screen, which is a lot of fun as well. We would love to actually see you. Who are you joining us today? Feel free to pose some questions to our amazing guests. But in the meantime, while we wait, John, Guillaume, I was very curious. So seeing that visualizer, are there any kind of limitations? What kind of AI applications can be visualized like that? That information is able to be turned into something visualized and usable for people who are not necessarily AI background minded, or is it fairly applicable across the board that it's open and possible to apply to almost any use scenario?
I mean, I think so. I'd say the strength here is computer vision models. The other example I have is a medical segmentation model, which if we don't have any questions, we can dig into that one as well. Any situation, the MNIST one is it's kind of interesting because almost any human probably can look at a number and give a correct judgment of what that thing is, right? That's a 7. Even if it's poorly written, as a human, we have a pretty easy time of differentiating a poorly written 7. I mean, maybe not in every case, right? I don't know, some handwriting is impossible to understand. But in more complex and higher risk scenarios, like you mentioned, especially in the medical field or industrial fields, the need to bring in domain specialists and other experts who are not just ML developers and have that shared process of looking at what the model has learned, at what patterns it's learned to recognize in those input pieces of information, it becomes more and more important. So specifically in the medical field, a model could be predicting something, but like I mentioned, it could be predicting it for the wrong reason. And so you need medical professionals working with the ML developers, working with the AI specialists to share that process, that development process, that visualization process, in order to have that kind of back and forth and say, okay, it's working for the right reasons, or it's not working, and this is why it needs to be fixed, and this is how it needs to be fixed. So, the visualization tooling gives kind of a shared language that people can interact with each other. That's not specifically domain specific terms. Like doctors have a lot of them, ML developers have a lot of them, but visualization or images are a place where you can kind of meet and say, oh, okay, well, it's that. What I'm talking about is that thing. That specifically is what I'm talking about when I say, pulmonary, whatever. I don't know any medical terms, so I won't try to make myself look too stupid. Yeah.
Awesome. Thanks, John. So I see we've got a couple of questions from the audience. I'm going to scroll a little bit back up because I saw, Gabrielle, you sent us a question a while ago, actually, so I'd like to touch on this one. So Gabrielle asks, so obviously accessible AI should rhyme with socially accepted AI. So how would you go about getting the general public to understand AI enough to not uselessly block its development out of fear?
Yeah, I mean, that's a tough question. I think it's a tricky subject. So, I mean, one of the things that's important is, there's an issue with training information, and it relates to another question that was asked. But, models by definition are kind of dumb, right? They're not really generalizable in the kind of general AI sense that I think some people think AI means or even are looking for, coming out in the future of what is a general AI intelligence. In the case of models that are recognizing things, often the problems with the data sets, so data sets that are incomplete or incorrect or missing big sections of the real world. This is a big problem with self-driving models, is that in order to get enough data to train a self-driving model, you often have to generate these, you have to simulate the data. And this can be problematic because your simulation may not represent the real world in any meaningful way. So even when you're trying to increase the amount of data you have, you're still kind of bound by the constraints of the developers, how they perceive the world, how they think of the world, and the data that's being fed into the model. So, I think to me, the important piece of this is understanding basically the limitations of data and the limitations of development, and kind of working, at least in an organizational concept or maybe in a social context, with kind of a broader group of stakeholders, a broader group of people who are able to contribute to this development process. And those are the kinds of things that can, move towards, just more generalizable and better performing AI, in addition to, what you might say is more acceptable AI or,
Yeah, I'm going to add a couple of things. This is a really passionate topic with us. I'll add two more things. Bias and test and evaluation. So the problem with AI is it doesn't know when it's being biased because it just takes data, right? And the algorithm doesn't get to choose the data it takes. Mm-hmm. We give it the data. So if I trained an algorithm, and the algorithm, for exactly the way Jonathan said it, for what you created it, it's really good at figuring out how to outsmart you. It really is. And so there have been plenty of examples where the algorithms has taken on one part of a data and said, aha, this is the driving factor that gives me the answer. So I'm going to cheat and forget all the other stuff. I'm just going to jump to the one that always seems to be the driving factor. So if I'm giving you a population of data which is ethnically biased or gender biased, then the outcome will go, oh, it's always a guy. So give me a CV, it's a guy, I'll put him on top of the list. Give me a criminal, it's an ethnic background A, I'll put him or her on top of the list. You see what I mean? And so the ability to open the black box and say, where is it biased? It is saying really, where is the data bias? Because the algorithm in and of itself is not biased. It's just smart at what it does. So that's number one. Number two is, I come from a world of modeling simulation software. Like I've done a lot of that in my career. And in that body of knowledge, we talk about software testing, software validation, software auditing, right? That whole, it's gone on for years. That doesn't exist yet in AI. So the concept of how do you test and validate AI to make sure it's doing the right things for the right reasons doesn't exist. And one of the areas that we're focusing on is really that part of the workflow to say, yeah, you can show your data, you can see inside, like John showed you, he said, why are you calling this a 7 versus a 9 or a 1 versus a 7? That's a typical one. Depending on a European one or a North American one, it can be a 7, right? Or the 4, it looks funny. And so what we've done is we've said we're going to make it visual so the bias can be exposed and people can have that conversation of the data and the output. And we're going to create an environment where you can do test and evaluation to address the question. Because until you do that, you're trusting the black box. You're trusting that, just like you and I would trust a biased individual in a job, it's no different. Unless you've trained that individual to look at the world differently, the data around the individual, it's still going to be biased, right? So that's what we're trying to do.
what I like from this conversation is at the end is everything about adoption. And I remember being in a nuclear facility in the US, and they have like tons of regulations and tons of warnings on where to get close and where not to get close. And they even use different kind of lights to make it more specific for people. You know, like even if you don't speak the same language, it'll be clear for you that if you see a red light, please do not get there. But at the end, what I like the most is this sign or this legend saying, machines don't have brains, please use yours.
Yeah.
So regardless if it's AI or if it's the printer from Gutenberg or if it's a nuclear facility, at the end, we are the masters of the technology we are developing. And it's important for us to recognize that. And it's important for us to appropriate those technologies and to identify, as Judd mentioned, what is the limitation of the technology and which are the potential avenues that we can explore with it. So it's fascinating.
So we have a question here from Alejandrina. I hope I'm pronouncing your name right. So
Alejandrina Vadillo.
To follow up on that, so to feed the data to recognize and learn, we introduce a range of emulated bias to actually find the higher bias. Is that correct?
Boy, I shouldn't have mentioned that I have a philosophy background, huh? I mean, if I'm understanding the question correctly, which I may not be, it's a very interesting point. And I think that could be a very interesting technique to discover. I mean, in many ways, you know, if the developers of the model, that when we're talking about cross-functional or like, multiple stakeholders approaching the development of a model, it's important to have representation of a lot of different viewpoints in the actual development, because the selection of the training data, the creating of the training data can actually represent the biases that exist already in the developers of the models and those types of things. So when there's certain groups of people who are the only people who are doing model development, then those biases consciously or unconsciously begin to get reflected in the systems that are created. So I think, yes, there's absolutely a level of higher bias and the discovery of that from some of the large scale failures we've seen in ML systems.
Yeah, I was going to add, because I've worked on a lot of projects on the consult. Not worked. I'm overselling myself here. I've overlooked a lot of the projects, and what I've realized is, the famous data that these data sets can be huge. By the way, like mega. That's why we call it big data. That's what machine learning is so good at. The human would take too long to understand all the data and come up with an answer. So that's the positive side. But these data sets have a lot of features in them. And what the machine learning algorithms and deep learning algorithms do is they figure out which of the features. I could give you 1,000 features, but really it's like the numbers that Jonathan was showing. There may be 3 or 4 key parts of the features that drive the majority of the results. And so you need different levels of bias, and understanding how each feature has a predominant role. And when Jonathan was showing the model in the demo, he showed you didn't see it at a macro level, but what he was showing you is going left to right, how the data is flowing, and each along the way of those different submodels, how each of those submodels, architectures, was having an impact on determining what was going on and how it would classify it. And so the question that we were just asked, it's understanding along the way what happens. I'll give you an example. We did some work with a company that was looking for boulder detection on railroad tracks. Okay, and the pictures that they had used to train the model was a boulder just before the track entered a tunnel. Boulder on a track just before a tunnel. If you take a picture of that, the boulder and the tunnel outline also looks like a boulder. The algorithm was actually telling the train to stop, so good decision, based on the shape of the tunnel. It interpreted it at the boulder, not based on the shape of the boulder. And so understanding, and we found that out after the 12th layer going left to right, that for some reason it said, haha, we're going to stop because I'm identifying this shape as a boulder, which is, if there had been no boulder, it would have stopped for no reason, right? And so the bias is understanding along the way, at what time did the algorithm say I'm putting more weight here? So top level bias, second level biases, as you go left to right, as we call it in the model architecture.
So we're running really close on time here, and I want to make sure I give you guys a little bit of time at the end to let us know how to follow you. But I do want to touch on one question here because I don't want to ignore our audience. Luke. So Luke asks, does the Tane product allow to visualize models not applied to 2D images like time series?
So yes. I'll give you an example. We worked on a what's called a wake word detection model. So when you say, "Okay, Google" or Alexa, there's a neural network that fires in those devices that's specifically designed just to detect a wake word. Its only purpose is hearing that one word and then firing and turning the device on and going and calling home for the larger system to start interacting with it. So, sound is a time series, it's a wave, right? But you can use a lot of different kinds of models. In our case, we use a computer vision model, and this was a particular model called Honk. It's using a computer vision model to identify patterns in a time series in the audio itself. And when you visualize it, it's actually fascinating because you can see what the wave pattern looks like, and you can start applying convolutional approaches or visualizations to that audio waveform in order to see where the model is putting attention on the waveform. And so similarly, how a model can learn a pattern in image data, which is, from the computer's perspective, it's just 784 unique values. There's nothing image-ish about it. That's just for the way we interpret information. Similarly, you can do the same thing with audio information, which is also just a series of values of different intensities. And so you could start pulling things like the 7 and 9 cases from the wake words. This is something we did. So we pulled, okay, here are the ones that are not performing very well. And you listen to them as a human and you say, oh, okay, obviously I can tell that that's not performing very well because it sounds like nothing or it's random noise. So there are many cases of the data being completely, someone says, go and stop, but it sounds almost exactly the same because the recording wasn't very good. And the model is saying, okay, well, I don't understand how to predict the difference between these two distributions. So yes, that is absolutely something it can do. So,
well, as per tradition, we always wrap the Innovators show with nominations. So most innovators know others innovators, whether mentors or someone they look up to, even rivals. So every show we like to dedicate a bit of time to hear from our guests. And I think the first question is, who is the most innovative person, organization that you know or that you've interacted that you would like to nominate and hear from in future episodes? And the second is, why are you nominating them?
That's me of us. Yeah. Sorry.
Yeah.
And for our audience too, you can write that.
Yeah.
That's a good question. Look, I think that having mentored a few companies over the last little while, I think that hearing companies like, Sarah Jenna out of MIMS, My Intelligent Machines, a great success story in genomics here in Montreal, using AI and genomics and a few other different things, I think would offer female leadership, tech, Montreal, in a pretty competitive environment. So these are that would be one person. The work that Sylvain Kyle is doing out of Founder Fuel now, taking all his knowledge as basically the guy who created Founder Fuel and exporting it to environmental and socially responsible initiatives. So all that know-how, how to build tech companies, but aimed at that part. I mean, those are just two very different profiles I would put forward, but those are certainly two very, very, interesting people that would have a lot to share and innovators in their own fields.
That's great.
Does someone come to mind, John?
I was answering questions in the chat.
No worries. We're right at 1 p.m. So actually, I don't want to hold you guys up too much longer. So, but I do want to dedicate a quick segment to you, or for our audience to follow you along for whatever's happening. This is kind of your time to give the call to action of, how do they follow you? What do you want them to keep an eye on? Take the next couple of minutes to let them know exactly that.
Well, on my side, I would have said, go to our website, but I will say go to our website in about a week or so, because we're releasing a brand new website with just a brand new look, but also a clearer way of navigating and finding great information. So that's a great way. Whichever the old or the new website, the free viewer is exactly that. It's free. It costs you nothing. There's no information. You just download it and you can start seeing what some of the stuff that Jonathan was showing you. They're more aimed at machine learning, deep learning models, but you can really play around very, very intuitively. So that'll be my second. And then the third one would be, for sure, if you're in a company that's looking to bring in AI and you've been struggling to do so, we'd love to have a conversation on that, for sure. So we can be found Guillaume@Zetane.com, John@Zetane.com, or visit Zetane.com.
Yeah, well, one of the things, just real quick, we're releasing is we're putting a curated set of models in the viewer itself. So when you download the viewer, there will be pre-curated models. So if you're trying to understand what models can do, you can actually just use the ones that are already built into the engine. So there's 5 of them of different kinds. So one is ResNet, just classic architectures that you can kind of look at and you can experiment with them. So they come with some free sample data, and you can see how the sample data is transformed as it passes through the image. And you can load your own data and pass it through without having to write a Python script or drop into code, just to kind of understand what's going on and maybe to validate if you have custom models. So.
Thank you, John. Amazing. Thanks again. One more time, let's virtually put together our hands and let's clap our guests. And smash that applause button just in the screen. And let's show them our community love. So if you enjoyed this episode, please share this with all the AI enthusiasts you have in your life or in your community. And over the coming weeks, we'll be posting highlights on the Montreal New Tech social media, so make sure to follow us. And if you haven't done it yet, feel free to follow us and to share and interact with us in social media. So Dennis, it goes.
Yes. So we're not really done yet. Do end up every show with a little bit of a breakout room. And John, Guillaume, I know you guys are very busy. If you have time, we'd love to see you in there. It's a place for our audience to interact and have a bit of a conversation post-show. So we'll have 2 breakout rooms open. One dedicated to continuing the conversation on AI. And the second one is what we call the VIP Innovators Experience. It's the behind the scenes of the show. So we always, our main goal is to always iterate, do better next time. So we open up the doors to our audience to join us in that other breakout room to let us know, how was the show for you? Did you enjoy yourself? What worked? What didn't? I know we can have a bit of a conversation about the mess up today with the game, for example. I'd love to hear if you guys would like us to try that again. We definitely would love to hear from you over there. So otherwise, thank you so much for joining us, Guillaume, John. It was a fantastic conversation, and we'd love to continue that afterwards if you have time, or otherwise we'll definitely be in touch with you guys by email. So thank you so much for joining us today.
Thanks for having us.
Thank you very much.
Thank you.
Great.